and welcome to another episode of STEM in Seconds. Today I'm going to do a quick recap of everything you need to know about circles for your A-level exams. So here's a little graph and here's a circle on that graph with a centre here and a radius of that. Now just like a line has an equation of y equals mx plus c, with m the gradient and c the y-intercept, a circle will have the equation x minus a all squared plus y minus b all squared equals r squared. From the letters you can probably guess that the centre of the circle will be at a, b, and the radius will just be r. So more often than not, you'll have to square root what comes after this equals. Sometimes you have to work out the centre from a given set of 2 points. So here is my line, and I'm going to say that this is the diameter of a circle, with one of the points at -4, 1, and the other point at 8, -5. Now this is the diameter of the circle, which means it goes through the centre, which I'm going to call M. There are lots of ways to find out the centre, and I typically prefer to do it in a visual manner. So I turn the diameter into a right-angled triangle. Here's a graph so you can follow along. The x-coordinate of this point is -4, here. The x-coordinate of this point is 8, here. So to get from -4 to 8, I have to go across 12. So this distance here is 12. Similarly with the y-coordinates, the y-coordinate here is 1, the y-coordinate here is -5. To get from 1 to -5, I have to go down 6. Now if I just redraw this out to -4 with just my top point and then use my midpoint as the other end of the line, I know that the midpoint is halfway between these 2 points. So if I turn it into my triangle again, I can then half the distances each time, so -3 and 6 to get to my midpoint. So the coordinates of M are going to be -4 plus 6 for the x-coordinate and 1 minus 3 for the y-coordinate, which gives me coordinates of 2 minus 2 for my centre. Now that I know the centre, and I know that 4 is a point on the outside, I can find my radius using a little bit of basic Pythagoras because I've got a right-angled triangle here. So my radius, or in this case for the equation my r squared, is going to be 6 squared plus -3 squared. So my r squared is 45. So for a circle with this diameter, the equation will be the equation is x minus 2 all squared plus y plus 2 all squared equals 45. If the equation of the circle arrives in this form, it's very easy to read off your radius and your centre point. But not all circle equations come like this. So the one we're going to look at is x squared plus y squared minus 14x plus 16y minus 12 equals 0. Which doesn't look very nice and at first glance doesn't even look like a circle equation. The easiest thing to do when you've got these 2 variables is complete the square to each variable. So first I'm going to line up my variables in order. So I've got x squared minus 14x plus y squared plus 16y minus 12 equals 0. And then it's a little easier to see how the completing the square would work. So my first is x minus half of 14 is 7 all squared, and then you have to minus half of b again, so -7 all squared, 49. Then we go to y, so y plus 8, because 8 is half of the 16, minus 64 for 8 squared, minus 12 is 0. And this is starting to now look a little more like a circle equation. So if I then bring this minus 49, this minus 64, and this minus 12 all over to this side, I get x minus 7 all squared plus y plus 8 all squared equals 125. And that is now in a form that I can read off that the centre of the circle is at 7 minus 8 and the radius is the square root of 125, which in this case is 5√5. When you plot a circle on a graph, something like this, and you have a line on the same graph, there are 3 possible options. The line can either not intersect the circle at all, it can form a tangent to the circle, otherwise known as one intersection, or it can cross the circle twice, forming two separate intersections. And if you're ever solving a simultaneous equation with a line and a circle, watch out. And usually it's a good idea to plot these on a graph and actually see how many solutions you're expecting. The final thing I want to do with you in this video is go through a quick worked example. So here's the practice question. It says that point A at -3, 7 is on a circle with a centre of 5, 1, and we're going to try and find the equation of the tangent to the circle at the point A. Now this is a geometry question, and the rule of thumb with geometry is always draw a diagram. So that's how I'm going to start. Here is my grid line. Here is the point A I know at -3, -7, and here is the centre at 5, 1. I'm going to draw a very bad circle around those points. So here is my centre, here is a point, which means that this distance here is a radius. So if I redraw just that line from -3, -7 to 5, 1, and turn this into the right angle triangle. Now in this case, the length of the radius doesn't actually matter. What does matter is the gradient of this line. Now why am I saying this? Because what we're looking for is the tangent at this point. And from an earlier rule, we know that tangents and radii are perpendicular, which means the gradient of this tangent will be the negative reciprocal of the gradient of the radius. Those are some long words, so let's work through it. Using the same method as earlier, starting with my x's, to get from -7 to 1 is 8 across, and to get from -3 to 5 is 8 up. Now the gradient of that is 8 over 8, so my gradient is 1. The rule with perpendicular lines is that the gradient of the first one times the gradient of the second one is -1. So 1 times the second gradient is -1, which means that the gradient of the tangent is -1. I now know a point on the line, -3, -7, which was given in the question, and I know the gradient of the line, which is -1. I can now form the equation of this tangent, because y minus y1, which in this case is -7, so y plus 7, is -1 lots of x minus x1, and in this case that's -3, so x plus 3. So y plus 7 equals -x minus 3, expanding that bracket, and moving everything to one side, y equals -x minus 10 is the equation of that tangent. Thank you all for watching. Please comment down below if you have any ideas for future videos, and don't forget to subscribe.